This lecture on Earth systems and human population will cover the final two learning outcomes of this week. First, we will explain the concept of exponential population growth and how it relates to resource use. Second, we will define the concepts of sustainability, ecological footprints, and environmental justice. This last learning outcome is covered not only in this lecture, but also in the extra reading and in the activities. Let's start by talking about possible ways populations might grow. One way that things grow is linearly. If you drink a cup of coffee every morning and then leave the dirty mug in your sink, but never do the dishes, the growth rate of dirty mugs is linear, 1 mug per day, at least until you run out of mugs. But not everything grows by a linear or constant rate. Some things grow faster and faster over time, where the bigger they get, the faster they grow. This is called exponential growth. Examples of exponential growth include how quickly mold spreads in a piece of bread and the rate of new infections in an uncontrolled pandemic. Compound interest in a savings account or unpaid credit card bill is a classic example. As you can see in this figure, at first, linear and exponential growth can look very similar. But over time, exponential growth takes off and your balance increases more and more quickly. This is good if it's money in a savings account, bad if it's your credit card bill. Given these patterns, what pattern do you think that human population follows? That's right, the global human population is growing exponentially. In 1800, the global population was about 1 billion. It reached 2 billion in 1927. It doubled again to 4 billion by 1974. Today, we are approaching 8 billion people on planet Earth. As we contemplate the consequences of exponential human population growth, we are forced to think about whether Earth can continue to provide for an increasingly large and consumptive population. This sort of thinking is not new. Back in 1798, the English economist Thomas Malthus postulated that population growth would eventually be limited by food production, which he didn't think could follow an exponential curve. Over the last 200 plus years, new technology and innovation in food production systems and increasing the land areas used for cultivation has allowed our food supply to broadly keep up with the population. We'll talk more about food production and its connection to soils in a few weeks. But at least so far, Malthus has not been right and exponential growth continues. Now people ask whether other resources might start to limit population growth in the future. Here are two examples of how our use of Earth resources has changed with increasing population. On the left, we see that global water use has been increasing about twice as fast as population growth since 1900. So here, our resource use is going up even faster than population. We'll talk more about freshwater resources in a few weeks. But in the tiny print, you might notice that this figure comes from a scientific paper about the threat of groundwater depletion, which means using more than is naturally replenished, and hints that our freshwater supply has its limits. On the right, we see that human activities have doubled the global availability of nitrogen. The extra nitrogen has come from the use of synthetic fertilizers, which we will talk about when we discuss soils. And it has come from fossil fuel combustion, which we will talk about in October. Excess nitrogen pollutes groundwater, rivers, lakes, and oceans, affecting fisheries and our freshwater supply. Together, these two patterns suggest that there are consequences of our pattern of population growth and resource use, and that increasing human populations cause more interference with all of the Earth systems. The idea that resources might eventually limit human population is seen in projections like this one, which shows a scenario in which the world continues to use the same policies it did in the 20th century. In this scenario, the resources needed to support society are declining or being used up. As they get used up, it gets harder to extract the remaining resources, and more capital, or economic attention, is diverted to extracting the resources. As a consequence, industrial output and food production decline, and population declines somewhat more slowly. This is not a pretty view of the future, especially when you take into account that these declines are projected to happen during our lifetimes. Is there maybe an alternative view? An alternative to resource overexploitation and the potential population decline comes from the concept of sustainability. Something that is sustainable can be managed for an indefinite period of time. In other words, it will never run out. A sustainable society lives within Earth's capacity to provide resources for future generations. Society and the economy are constrained by environmental limits. One way that we can assess sustainability is through the concept of an ecological footprint. An ecological footprint is a measure of human demand on Earth's biosphere. A footprint takes into consideration the stuff that we use in our lives, including food, shelter, mobility, goods, and services. It looks at the full life cycle of that stuff by considering the environmental impact of obtaining, using, and discarding it. The power of calculating ecological footprints is that it allows us to compare human demands with Earth's ability to regenerate the resources and provide services. Footprints can be calculated at the scale of individuals, companies, a town, a state, or a nation. You will calculate your ecological footprint as part of this week's online assignment. Ecological footprints are often expressed as the area of biologically productive land and sea needed to support the human lifestyle. Around the world, the average person's lifestyle requires 2.75 hectares, or 6.8 acres. Here's a map of the global distribution of ecological footprints by country. It probably won't surprise you to find out that the American lifestyle requires more resources than the average global citizen. Americans use an average of 8.1 hectares or 20 acres of biologically productive land. Take a moment to think about why Americans have ecological footprints almost 3 times larger than the average person around the world. What does an ecological footprint look like for an American individual? Here I am sharing my footprint from 2018. As I said earlier, you will calculate your own in this week's online activity. My 2018 ecological footprint of 5.5 hectares is lower than the average American, which remember is 8.1 hectares. The biggest component of my footprint was related to mobility, and a lot of that was plane flights to see family abroad and for professional meetings in other parts of the U.S. A component of your overall ecological footprint is your carbon footprint. And you can see that for me, it was about 61% of my total ecological footprint in 2018. But what does an ecological footprint like this mean in terms of sustainability? Knowing your ecological footprints alone isn't enough to assess how we are doing with sustainability. For that, you also have to know the amount of bioproductive land and water that is available. Right now, there is 1.6 hectares of bioproductive land available per person in the world. That means with an average ecological footprint of 2.75 hectares per person in the world's average lifestyle is not sustainable. Note that as human population increases, the bioproductive land per person decreases, which is why it's important to reference that this estimate of 1.56 hectares per person is in reference to a population of 7.8 billion. Given a few years, and there will be less bioproductive land per person because the global population will increase. Where does this leave us? We have overshot global biocapacity by about 60%. We can think of that in terms of what day of the year we might start to exceed what Earth can regenerate in a year. In the graphic on the right, you can see that the overshoot day has gotten earlier and earlier for the past 3 decades. That means we are collectively overshooting Earth's biocapacity more each year as a product of our increasing global population and our consumption patterns. In 2020, the global overshoot day is August 22nd. Economic and travel disruptions associated with COVID-19 have moved it back about 3 weeks. In other words, the pandemic has lowered our global ecological footprints. However, most people assume that when the pandemic is over and things return to normal, we will continue to overshoot earlier each year. I wanted to see what effect a few lifestyle changes and COVID-19 had on my ecological footprint, so I recalculated it for 2020. Without any plane flights this year, my mobility score has gone way down, affecting both my overall ecological footprint and my carbon emissions. This is good from a sustainability point of view, but I miss my family. So my personal challenge will be to see what other lifestyle changes I can make before I start flying again that will help keep my footprint lower like this. As you do your ecological footprint calculations this week, think about how your footprint may change over time. What happened when you moved away to college? What will happen when you graduate?